Adab, my respected sir. I am Monisha Raimo, my ID 171291025. Today our presentation topic, how conjugated double bonds affect lambda max value. So at first, introduction of conjugated double bonds. Conjugated double bonds in a molecule mean that the single and double bonds alternate. Or another lambda max, the wavelength at which a substance had its strongest proton absorption. Now we know that UV-Vis spectroscopy help us to understand exactly how conjugation relates to the lambda max value of a molecule. For example, let's look at what happened to lambda max when we increase the conjugation ethene to butadiene to hexatriene to octatriene. Now ethene 1 pi bond lambda max is a 174 nanometer, butadiene 2 conjugated pi bond lambda max is a 217 nanometer, hexatriene 3 conjugated pi bond lambda max is a 258 nanometer, octatriene 4 conjugated pi bond lambda max is a 290 nanometer. So longer the conjugated system, greater the wavelength of absorption maximum. Actually, fewer conjugated pi bond, lower lambda max, and more conjugated pi bonds, higher lambda max. As the number of conjugated pi bonds increases, the lambda max increases as well because longer frequency equals smaller energy. This means that the energy gap between the highest occupied molecular orbital HOMO and lowest unoccupied molecular orbital LOMO decrease as the number of conjugated pi bond increased. This picture energy gap of conjugated polyene. Now compare molecular orbital picture of ethylene to butadiene. We see that the HOMO and LOMO energy gap is indeed smaller for the conjugated system. Butadiene absorb UV light with wavelength of 217 nanometer, which is greater than the wavelength of ethylene. As conjugated pi system become larger, the energy gap for a pi to pi transition becomes increasingly narrow and the wavelength of light absorbed correspondingly becomes longer. Again, compare molecular orbital picture of butadiene to hexatriene. The molecules with extended pi system, the HOMO and LOMO energy gap becomes so small, so its wavelength is greater than butadiene. Or another, hexatriene compared to octatriene, its wavelength is greater than hexatriene because the energy gap becomes too much small. Thank you.